Manny's here. I see Elizabeth is here. Hi. Glad you all are here this morning. All right. Great. Welcome, everybody. So those of you who are here joining us on Zoom, welcome. Go ahead and introduce yourself in the chat. Let us know where you're from. And we will go ahead and get started. All right, so good morning, engineers, and welcome to your Environmental Engineer Research Team meeting. We're so glad to have you all here this morning. So welcome to all of you who are joining us here on the Zoom call. Just a couple of things for those of you that are here on Zoom. We are going to be using the chat today as the way that we communicate with each other. So feel free to introduce yourself, say hello, and this is the place where you all are going to share your thoughts and your ideas about engineering and about this project that we did together. So let's remember to use the chat for that. And that's all we're going to use that chat for today. So we're going to use the chat for science and save other things for another time. Welcome also to all of you who are joining us on the live stream today. So I hope that you all are going to be having conversations in your own chats as you watch us here on the live stream. Hi, Brannan, welcome. Glad you're here this morning. Delia and Declan are here. Excellent. Wonderful. All right, we're glad you all are here this morning. There's another thing I want you to know is that our research team is not the only research team that has been working on this project today. I'm going to show you a map. Oops, there we go. So there are research teams all around the country who have been doing this same work that we have been doing with our research team. So every red dot that you see there on the map is a place where there are folks just like you solving these same problems this summer with GSK Science in the Summer. So lots of different people and ideas coming together to solve these engineering problems. All right, so our engineering team was the environmental engineer research team. So we know that engineers are people who solve problems. What kinds of problems do environmental engineers solve? When we were working on this, what kinds of problems do we solve, or what do you remember about what other kinds of problems environmental engineers solve? Go ahead and type in the chat, what kinds of problems do environmental engineers solve? Hey, Nicholas. Hi, Hannah. Tristan, glad you're here. Culverts, says Marie, natural disaster prevention, right? So thinking about natural disasters that might happen and how we could prevent them. Problems that are outside, right? It says things like flooding. Chiaka says reducing pollution, maybe water pollution. Problems that involve nature. Yeah, Michael says they solve problems to protect people and the environment, right? Environmental engineers solve problems that have to do with keeping land and air and water and the people and the animals that live in them safe. Wonderful. So having had a chance to practice being an environmental engineer with these activities, I have a question for you all. I'm wondering whether this activity made you more interested in being a scientist or an engineer one day for your job. So I'm actually going to put up a poll question. So you should see a little box pop up on your screen that's going to ask you that question, and you'll have a chance to answer. Did it make you a lot more interested, a little bit more interested, or not really interested? So go ahead and answer that question, because I'd like to hear what you think about that. And if anybody does not see that box popping up, and some people don't, you can go ahead and just put your answer in the chat. Oh, Bryn says a lot. Elizabeth is interested in being a vet. Very cool. I wonder if vets have to solve problems. All right, we've got a little bit. Bryn likes engineers. All right, someone else is interested in being a zoologist or a vet, so interested in animals. Great. Yeah, Eric, so unfortunately that's not the name. I see the name John in the chat. So I'm sorry if I can only call you the name that I see. All right, let's give you one more minute to answer that poll, and then we'll go ahead and see the results. Okay, so let's go ahead and close that poll and let's see if we can show you what everybody said. All right, so if you can see those answers there, that red one, most of you said it made you at least a little bit more interested in being a scientist one day. Some of you maybe were already interested in being a scientist or an engineer. Some of you said a lot, and some of you said not at all, and that's okay too. Some of you already have other ideas about what you want to be when you grow up. Wonderful. All right, so we had a chance to try out being environmental engineers. We had a particular project that we were working on. So let's just remind ourselves what we were working on. So if you remember, our job for our environmental engineer research team was working on a rainwater system, right? It was our project to work with a city who was trying to build a playground on the side of a hill, and they were worried about rainwater coming down the side of the hill and maybe flooding the playground. So it was our job to think about where we should put the playground on that hill and how we could make a system that would keep rainwater away from the playground when it rained. And you might remember that we did what a lot of scientists and engineers do when we have a problem that's really big, like a whole side of a hill that's pretty hard to practice on. We use a model, something that was a little bit smaller that could help us get some ideas about how to solve the problem. So you can see that picture on my screen. Most of you had something that looked kind of like that. We used a tray to be a model for our hillside, and we tried to do some research to figure out how we could solve this problem using this model. Greathead says they did great. That's wonderful. I'm looking forward to hearing the ways that you figured out to solve the problem. So let's get ready to hear about your research and what you found out. So hopefully you all have your lab notebooks ready where you wrote down some of the things that you researched and found out so that we can hear from you what you discovered. So the first thing that we were supposed to do was to figure out what happened when we poured water on our model. What happens when it rains on our hillside? So why don't you go ahead and tell me in the chat, when you first just poured water on your model, on your hillside, what did you notice? Where did the rainwater go? Megan didn't get a lab notebook. I'm sorry. I hope you had a chance to at least remember some of the things you did. Talia says the water went down the hill. Kristen says it went down the side. Okay, lots of you say it went to the bottom. The water went down. It went to the bottom. Gloria says it all flooded in the bottom, so it all kind of collected at the bottom of the hill. Isabel and Emily says the rainwater went to the bottom and spread out. It went everywhere. And Raydad said it slowly trickled down. Interesting. Down the hill and mostly to the sides. It went through the dots. So there were some little bumpy dots on your hillside and it went sort of around and through the dots. Down the hill to the bottom, it all kind of pools at the bottom. Interesting. So it looks like a lot of us found the same result. So the water mostly went sort of down to the bottom of the hill and kind of sat there at the bottom of the hill. Yeah, Raydad said the bubbles maybe slowed it down. So those little bumps in the hill maybe slowed down the water. Great, so yours went into a channel, into a retaining pond. Excellent. All right, so it sounds like we had a lot of the same results there. See, the water went down, maybe it slowed down a little bit. So then our next question to think about is, now that we know where the rainwater goes, where on the hill should we build our playground? So what did you decide? Where did you decide was the best place to put the playground? Go ahead and tell me in the chat. Avery says the top, right? If the water's all going to go down, maybe it makes sense for it to go in the top. Some of you chose the middle. Lots of people put it on the bottom. So at the bottom. Chiaka put it on the bottom. Isabel and Emily put theirs on the bottom. That's interesting. So we noticed that the water all went to the bottom. For those of you that put it on the bottom, why did you decide to put it on the bottom? John says they thought that was where you were supposed to put it. That's fine. Maybe that's what the city asked us to do. Maybe they really want it to be at the bottom of the hill. Ah, okay. So lots of you thought maybe that's where it was supposed to go in the first place. It makes sense, right? You might want a flat place to put your playground. But that makes some interesting problems to solve, right? If you need to have your playground at the bottom of the hill, but that's where all the water goes, how do you solve it? Oh, Ajay says maybe they thought the water would drain faster if it was at the bottom. Elizabeth chose the top because it doesn't get flooded. Wonderful. Good. Any other thoughts and ideas about where you put your playground and why you decided that? Isabel says it seemed like it drained and soaked up faster. All right. Great ideas, everyone. So I can tell you're thinking already about what problems you might have to solve that might be different depending on where the playground is on the hill. Very cool. Good. Well, before I hear more about all of the solutions that you are thinking about, I was wondering if you could help me with the one that I am working on. Because I've been working on trying to design a rainwater system for the playground as well, and I'm running into some problems. So I'm hoping that maybe you can help me. So I'm going to actually switch my video. So give me 1 second. I'm going to show you a video of the one that I'm working on. So I'm going to disappear for a second here. And then, all right. All right, so there is a view of the model that I am working on. So you might notice that it looks a little bit different from yours. I don't have the little dots, but I have kind of lines on mine. But it's set up so that this is the top of the hill over here. So if I tilt it so that you can see, right, this is the top of the hill. I've got a book under here so that it slants down. And this is down at the bottom. And I decided that I'd like to put my playground where you see this black box. So kind of towards the top and on the side of the hill so that the water will collect on the bottom. I was kind of inspired by that picture that I showed you earlier of the playground that was on the side of the hill, and I thought that would be pretty cool. So I'm going to put my playground here where this box is, and I've started trying to build something because I noticed that the water ran down through my playground. So I started trying to build a barrier that would protect it. Let me just show you a little bit what I thought. So I started by using a craft stick, right, to act like a wall, and I have some Play-Doh there to hold it in place. But the first thing I noticed when I put the craft stick there was that the water leaked underneath. So I also added on this side, it's a little bit hard to see because it's the same color, but I added some aluminum foil here to kind of plug up that hole. So that's what I have so far. And I thought I would test it, and I'd like you to take a look at it and let's see what kinds of problems we're having that you could help me solve. So I'm going to add some water, and I put some blue food coloring in my water to make it a little bit easier for you to see. So I'm going to add some water to my model. All right, so what did you notice about what's happening to the water in my model? Gloria says that's what you did too. Very cool. So we had the same idea. Wonderful. So as we're watching where the water goes, there are a couple of things that I was noticing. The first thing, yeah, so Isabel says the water all collected in front of the playground. It's all kind of getting stuck and built up here at the top. So the playground part is staying dry, but the water's all sitting up here. So let's think about what that would be like in real life. So in real life, what do you think this is going to look like if this were grass and dirt and all the water sat there? Yeah, so some of you did it differently. Yeah, you're right, Yuan, that water doesn't rain exactly that way. So our model isn't perfect, right? So we were just testing what it would look like if the water ran from the top down. Yeah, Mia says there would be a giant muddy puddle or squishy grass. The grass would flood, right? So I've solved the problem of keeping my playground dry, but now I've got kind of a squishy muddy puddle here at the top. Isabel said it might be filled with mosquitoes, right? That's not going to be so good for a playground either. Yeah, Delia noticed that it went around the playground, but it pooled up against the wall. And if it rained again, there would be a flood, right? So if it kept raining and it kept building up, it might just go over the wall. That would be not so good, right? And another thing I'm noticing too is that even though the water went around the playground, it's still collecting really close to the playground. So again, I think some of you had the right idea that if it kept raining, it might start to rain in the playground. So I've solved a beginning of a problem, but I could probably make this better. What do you think I could do that would help it not build up there? Now here, some of you have some ideas already. Say have a slanted wall. What if the wall was diagonal? Interesting. So the wall is straight. What if I made it diagonal so that it sort of followed the lines there? Maybe that would help it. Let me see if I can try that. So I'm just going to empty the water out. Let's see if I can move my wall so that it's a little bit more diagonal. Might need a little more tape to hold it down. I'm going to give it a little more tape and then we'll see what happens. Elizabeth says, make the wall as tall as you can. Right, so maybe I just need to make the wall a little bit taller so that it will keep the flooding from happening. That's another idea that we could try. Oh, I see some other good ideas happening too. So maybe adding something that could soak the water up. I'm going to keep that idea, some of those ideas in my head. Make another wall so it looks like a slanted L. Oh, interesting. So maybe something that keeps it going a little bit farther. Wow, so many good ideas. He says make it an indoor playground. Maybe if we covered it, then we wouldn't have to worry about it. That's an interesting creative solution. All right, so we've got a couple of ideas to try. Let's start with this slanted one. So let's test it again. Pour myself a little more water. And let's see if that helps with the water building up. So I'll pour it back and forth just like I did before. All right, so what did we notice? Summer's too hot anyway, let's go inside. Yeah, on a day like today, you might wish for an indoor playground. All right, so it looks to me like we don't have a puddle here. So slanting it seems to have solved that problem, which is great. But I am noticing still a lot of water over here. So I liked, yeah, still too close to the playground, says Aaron, right? Talitha noticed that less water collected. Yep. Yeah, so lots of you are saying, what about an indoor playground? That's definitely a solution, but let's think about how much work it has to be to build walls and a roof and all of that kind of stuff. And what if it's a really nice day out? We want to have an outdoor playground, right? So what our people that we're working with, the city, what they have asked for is an outdoor playground. So that's definitely a way to solve the problem. Maybe not the way that's going to work for this one. Yeah, so Delia said less pulled up against the wall, but we still have lots of puddles over here. Yeah, so what could we do? We could extend the wall, we could make it longer, but the rain would still, yeah, you're right. Yeah, so I see some folks saying maybe we could put something in there that would help to absorb some of the water, or we could make the wall longer. Let's see, let's start with absorbing the water and see what happens. I'll get my cotton balls. Declan wants it to flood. Yeah, when we're working with a model, sometimes it's fun to watch it flood. But imagine if you were going to a real playground and you got there and you couldn't play in it because it was all full of water. All right, so I'm adding some cotton balls. So I wonder, we're using cotton balls in our model, but what do you think we could use in real life that would help to soak up and absorb the water? You can tell me in the chat what you think. Probably we're not going to use real cotton balls in real life, but what would we use in real life that could soak up the water? All right, so let's see what happens. Got some cotton balls there. All right, what do we think about that solution? We could use a drain, right? So if we have a drain, we need somewhere for the water to go, so maybe a pipe. Megan says things like soil and grass. Yeah, bushes and plants actually soak up water because they drink it. So maybe these would, in real life, these cotton balls would be plants or soil or something like that. Water-loving plants. What did we notice? Yeah, so Avery says it seems like it works a little bit better, right? So you can see the blue where the cotton balls are soaking up the water. Aaron says it helped, but there's still water over here. Yeah, so maybe we want to think about adding another wall or extending the wall. Excellent. I don't have, let's see if we can make our wall just a little bit longer. So for this one, I'm actually going to just use a piece of aluminum foil just as a test to see if making our wall a little bit longer would help. So what if We just made our wall. So kind of like that. I'll just put a little tape to hold it down. We'll test it one more time and see what happens. And just put cotton balls all along the playground. Interesting. So cotton balls are plants. Maybe we want to put those along there to soak up the extra water too. Well, maybe we'll try both of those ideas together. All right. First, we'll try the wall, and then maybe we'll try adding some cotton balls along the edge. All right, so there's our temporary wall. Let's give it another test and see if that helps. Pour in the water one more time. Whoop. What do we notice about that one? Interesting. One says maybe there needs to be a drain inside the playground so that the rain inside will also go down. I think you're right? In our model, we're only pouring at the top, but the rain might actually fall right there as well. All right, so it looks like I had a little bit of a problem with a leak here on that side, so I'd have to fix that problem. Yeah, it got worse, right? So it just sort of collected. So maybe that's not the best place for my wall. I might think a little bit about another way to make a wall, but let's try out the cotton balls that someone else suggested. So what if we put something to soak up the water right along there? All right, try this one idea. So you guys have given me lots of ideas for how I can make this work better. Oh, we've got just a little bit of water left. So this is going to be our last test. We'll give it one more test and see what happens this time. All right, what do we notice? At least from, yep, nothing. So it looks like, at least from what I can see, any water that kind of trickled down here got soaked up by the cotton balls. So maybe that's a solution that I want to think about. Yeah, the cotton balls soaked up the water. Yeah, he says, now I really do need a drain at the bottom, right? Look at all that water that's collecting down at the bottom. So we definitely need somewhere for that rainwater to go. But it looks like I've got some good ideas about how I can at least protect the playground that I'm working on. Wonderful. Well, I still clearly have some more work to do, but thanks to you, I have some great ideas about how I can improve the system and maybe get something. If I add all those ideas together, maybe I'll get something that will do an even better job of protecting my playground. Yeah, what if some rain gets in, right? So we still have some other problems to solve. Maybe we do need to have a drain inside the playground, maybe another wall on the other side. Oh, wonderful, great ideas. All right, I'm gonna go ahead and switch my video back. So we're gonna make that disappear. And then make my face reappear. All right, wonderful. Well, thank you all so much for your ideas. And as you probably noticed, I didn't try just one idea. I tried a lot of different ideas, and I still maybe don't have the final solution that I want. In fact, let me show you. Here are some of the other ideas that I tried when I was thinking about my solution, right? I tried lots of different ideas. And before I even hear about the solutions that you came up with, I'd like to know, how many different ideas did you try? Did you try just one? Did you try 10? Did you try 100? Go ahead and tell me in the chat, how many different times do you think you tried before you got your best solution? Megan says, well, a really big number, 789066434. Avery tried 3 different times, 2 to 3 times. Aaron tried at least 10, 11, 3 or 4 different ideas. Some of you had a good idea right from the start. Really, really a whole lot. Elizabeth says, oh, your first idea worked well. That's great. Yep, and some of you said maybe just one idea, but maybe you had to improve it over and over again. So it wasn't exactly perfect from the start. So it was a good idea, but you needed to improve on it. Yeah, and that's part of being an engineer, right? Part of what we do as engineers is try an idea, see if it works, and then see what we can do to make it better. And if it really doesn't work, then maybe we need to change ideas. But sometimes it's just about taking that idea and making it a little better, and a little better, and a little better. Ajay says they tried twice. Gloria says their 5th idea worked. Nahul says there were 5 different ideas that all combined. Yeah, that's kind of what I just did in my example, right? I had an idea, and then you gave me one idea, and someone else gave me another idea with the cotton balls, and we kind of combined all those ideas together. Aaron says they had to add to their idea. An ice cream wall to catch the water. I'm interested to hear more about that. Yeah, so I'd love to hear from you. What are some of the things you tried that worked? Did you try walls like I did? Did you try the cotton balls that someone suggested? What did your solutions look like? Or what did you try that worked? Maybe you still haven't found the perfect solution, but what did you try that worked the best? Go ahead and tell me in the chat. Gloria used clay to prevent leaks, right? So I had that problem with leaks between the 2 parts of my wall. Maybe if I had put some clay there to stop the leaks, that would be great. Anyone else? What are some things that you found that worked well? Juan, did you actually make a drain? That's really cool. I'd love to hear how you made the drain. Bryn made walls and cotton balls. Wow, some of you actually made drains. Interesting. So you made pipes that could go to the river to catch the water. Anjay used cotton balls for extra support. Right, Megan says they did a chute with cotton balls and Play-Doh and popsicle sticks. Interesting, so sort of a chute to make the water go where you want. Like lots of you used cotton balls to help soak up the water. So maybe in real life, you'd be thinking about planting plants or putting some dirt places. Jamie put the playground on the hill at the bottom and then drained the water. Oh, we ran out, maybe drain the water somewhere else. Got a triangle wall and a drain. Yeah, lots of us use cotton balls and craft sticks to block the water. Also made a wall to protect the playground. Gloria says, yeah, a V-shaped wall worked too. Interesting. So maybe a V to kind of funnel the water where you want it to go. Great, interesting. So lots of you came up with some of the same ideas. Walls made around the playground, says Manny. Yeah, Elizabeth, I wish we had a way for you all to show us your ideas here on the call. Unfortunately, we can't, but it would be great if you wanted to show us on social media, or if your grown-ups can send it to our email address. We would love to see some of the pictures of things you made. I'm sorry that we can't all share them with each other here on this call. Well, that's interesting. So Isabel and Emily had the idea to make the playground on stilts. So what if everything on the playground was up above and then it wouldn't matter if the water went underneath or on a platform? That's a really creative solution to the problem. Yeah, so that would be fun, but we might have some other things to think about, like safety, right? We'd have to have railings or walls to make sure that people didn't fall off. Yeah, that's right, Elizabeth. If you'd like to just tell us what you did in the chat, that would be great, and we can imagine it. Yeah, interesting. So if the playground were on a platform, yeah, there's some other safety concerns we'd have to think about. Avery says we'd have to think about it being strong enough so that it wouldn't fall if there were too many kids on it. Wow, so many different ideas. So it's great that we had a whole team of people working together, coming up with all kinds of different ideas and solutions for this problem. So I think we have some great different ideas that we can share with the city about different ways that they could make this playground safe and not flooded. So that's wonderful. So I'd like to think a little bit about what it's like being an environmental engineer and how people get to be environmental engineers. I wonder, do any of you guys know someone who's an engineer? Maybe not an environmental engineer, but any kind of engineer. Do any of you know anyone who's an engineer? Anna does. Gloria does too. Yeah, Swati's dad is an engineer. A software engineer, says Marie, right? So there are all different kinds of engineers. Software engineers are people who solve problems with computer programs. Yeah, I knew an engineer. My grandpa was an engineer and he was a sound engineer. So his job was to design things like auditoriums so that the sound goes where you want it to go and it doesn't bounce off walls and become noisy. Lots of software engineers. A traffic engineer designing problems with traffic signals. Wonderful. Yeah, so lots of different kinds of engineers you can be and lots of different ways that people get to be engineers. In fact, I wanted to share with you someone who is an environmental engineer. There's a picture of her up on my screen. So this is Draisha J. Brannan. She lives in Portland, Oregon, which is way on the other side of the country from us here in Philadelphia, but she is an environmental engineer. But she didn't start out growing up thinking that she wanted to be an engineer. When she was growing up, she was actually really interested in art. She liked painting. She liked making things like jewelry and working with fabric. And she also really liked helping people. So she did lots of volunteering as she grew up. You can see a picture of her there in the middle where she was collecting toys for kids that didn't have them. And she didn't actually learn about engineering until she got to high school and started working with robots and robotics. But eventually she realized that she could use engineering to bring together all the different things that she liked. She could use engineering to be creative the way that she was in art and to help people the way that she liked to do when she was volunteering. And so she became an environmental engineer working for the city of Portland, where she lives. And her job in the city of Portland is to manage things like rainwater, just like we did in our project, to make sure that the people who live in Portland stay safe and also the environment around them stay safe. So one of the projects that she worked on was working with a park in Portland and designing rainwater systems, very much like we did, to make sure that the rain didn't damage the trails that people use when they're in the park, but also to make sure that the rain didn't damage the plants and the animals that make the park beautiful. I mean, I know someone who lives in Portland, Oregon. Wonderful. Maybe they've even been to the park that Jay worked on. So she works on now all different kinds of projects that have to do with water and managing water in Portland. And if you're interested in learning more about her, there's actually a video about her, a short video that NBC News did. We'll put the link in the chat there. So if you'd like to find out more about Jay and how she got to be an engineer and the kind of work that she does, you can find out more about her there. But that's great because it's a good reminder that you don't have to know that you want to be an engineer and that lots of different things and interests are important for being engineers because there are all different kinds of problems that we need to solve. And so we need all different kinds of people with all different kinds of interests to be able to solve those problems. So whatever you all are interested in, even if you're not interested necessarily in environmental engineering, but if you're interested in music, if you're interested in sports, if you're interested in dance, there's probably engineers who solve problems related to all of those things. So that's why I'd like to think a little bit about how you all were like scientists and engineers today. So if you have your lab notebooks, you probably also noticed that there were some stickers that came with those lab notebooks, and there were things on those stickers that are all things that scientists and engineers do, right? Observing things, trying again, having ideas, having fun. Maybe you had a chance to think about when you were doing this environmental engineer activity, which of those things did you do? So I'm going to put up another poll question that asks you to think about all the things that you did that were like an engineer. So how did you think or act like a scientist when you were doing this be an environmental engineer activity? Did you observe? Did you test? And by the way, you don't have to pick just one. You can pick as many of these answers as you want. Did you try again? Did you ask a question? Did you have an idea? Did you learn something new? Did you work together with someone else? Did you have fun? Those are all things that scientists and engineers do. And again, if you didn't have the stickers or if you can't see the poll, you can go ahead and put your answer in the chat as well. Yeah, someone said they did all of those things. Wonderful. Aaron did all of them. John fit all the answers. Lots of you think you did all of them. All right. Great. We'll give just a few more minutes to answer the poll, and then we'll see what the poll says. Gloria says their mom and dad worked with them. Yeah, so you worked together with the people in your house. That still counts as working together, definitely. All right, let's go ahead and close that poll and let's see which one people think they did the most. Oh, a lot of really close answers here. So a lot of you did all of these, but look, the one that had the most votes was for having fun. That's fantastic. So did you know that scientists and engineers have fun? If you have fun, that's definitely something that scientists and engineers do. That's great. So I have one more question. Some of you did it at camp, right? Okay, so maybe you worked together with other folks that you did at camp. Declan and the dad worked together. Great. All right, I have one last question for you. Since we're thinking about being scientists and doing scientists, did this activity show you that you can do science? Do you think it showed you a lot that you can do science, or just a little bit that you can do science, or it didn't show you at all? So go ahead and choose an answer. For this one, you get to choose just one. And again, if you don't see the poll pop up and you just want to type in the chat, did this activity show you a lot that you can do science, a little bit that you can do science, or not at all? Jack, if things not at all, I'd be interested to hear more about that. Some of you think it showed you a lot that you can do science. A lot from Bryn, a lot from Mia. Disha says a lot. Isabel and Amelia says a lot. Maybe a little. So punched, so that's how you made a drain, Elizabeth. You punched a hole in the bottom, and so the water could go through a gutter and into a filtration system and into the ocean, so the water won't fill up. Wow, so you're solving all kinds of problems. So you're solving the problem of the playground, but you're also solving the problem of making sure that the oceans don't get polluted. Wonderful. Great ideas. All right, let's go ahead and close that poll and let's see what you thought. Yeah, so a lot of you think that this activity showed you a lot that you can do science. Getting to solve problems like an engineer helps you think about the ways that you can do science. Wonderful. All right. Mia says, really, really a lot. So many a lots, it's taking up a whole chunk in the chat. Great. Well, I'm glad you all had a chance to try out being a scientist and being an engineer through this environmental engineering activity. And we talked about the idea that there are lots of different kinds of engineers. And there are some ways that you can try out being more engineers if you haven't already. So on the Science in the Summer website, there are 3 other types of engineers that you can try out being: electrical engineer, structural engineer, and biomedical engineer. So if you haven't tried some of those out, you can go to that website. We just put the link in the chat if you'd like to try out some of the other activities and see what it's like to be a different kind of engineer. But remember, engineers solve all kinds of problems. So if there's something else you're interested in, like music or sports or animals, there's probably an engineer solving problems around those things. So you could also do some research and find out, what kinds of problems do engineers solve about music? What kinds of problems do engineers solve about animals and vets and veterinary medicine? So feel free to keep thinking and learning about different kinds of engineers and what you can do to be an engineer as well. Gloria is looking forward to doing the electrical engineer activity. Wonderful. Great. Delia, I'm glad you had so much fun and are planning to keep going. Yeah, some of you are going to do the electrical engineer activity next. That's great. Be happy to hear what you think and which one you like better. Would you rather be an environmental engineer or an electrical engineer, or both? Wonderful. All right, well, thank you all engineers for all of the work that you have done today, thinking about engineering and helping us solve this environmental engineer problem. I also want to say thank you to GSK, who made this program possible for us to try out being environmental engineers. And thank you for joining us all today. If you have other questions, we have just a minute or two. I'll stay on the line if anyone wants to ask questions. Otherwise, we'll see you at some of our other research team meetings. And if not, I hope you'll keep thinking about engineering in everything that you do. Oh, thanks, Marie. This is a lot of fun. Thank you all. All right, have a great day, everyone. See you next time.